right, this is our last lesson for this chapter. It's pretty simple. We have a few theorems that we're going to learn and how to apply them. So the first thing I want you to do is to go to this website, okay? You need to type this in. It is case sensitive, so make sure you've got those capital and lowercase letters typed correctly. Okay, when you go to the website, okay, you can click on side lengths and it'll give you the side lengths of each of these portions of the triangle. And then it'll actually give you the ratio for you. Okay, and I want you to notice, oh, and we also have DE, okay, and BC are parallel. Notice that if we drag and change the shape of the triangle, or the triangle where it is, notice how those ratios stay the same. It doesn't matter what those side lengths are, the ratio is going to be equal to each other. Okay, so we have a few theorems that have to do with that, and you can even move this line, sorry, E, you can move this line, okay, and notice how even though that line is in a different place, the ratios still stay similar or equal. Okay, I could move this way over here, and then I move this and the triangle around, and those ratios still stay the same. Okay, so compare the ratios of AD to DB and AE to EC. What's happening? Well, we notice ratios stay equal no matter how we move the triangle. Okay, so we have three theorems that goes with this. The first one is the Triangle Proportionality Theorem. It says that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so over here it says if TU is parallel to QS, then RT goes with something and RU goes with something. What are those somethings? Well, RT is going to go with TQ, okay? And RU is proportional with US, okay? That's how you would write that. The next one goes the other way. It says that if they're proportional, then obviously those two lines are parallel. Okay, so if a line divides two sides proportionally, then it is parallel to the third side. Okay, if we have three parallel lines, okay, then they divide the transversals proportionally. So here we have UW goes with YW, just like VX goes with XZ. We can set up proportions that way. So let's try out a few problems. Okay, find the length of VW. This is what they want us to find. Okay, so we can set up our proportion. We know that VW goes with 12. Okay, just like 10 goes with 8. And then we cross multiply. 8 VW equals 120. Divide both sides by 8. And we get 15. Okay. And number 2, it says determine whether AB is parallel to XY. So in order to see if these two lines are parallel, that's what we're trying to find, we have to check that these proportions are equal. So does 3/4 equal 4/5? Okay, so let's just put that in the calculator. What is the decimal for 3/4? Okay, isn't that 0.75? Okay, and then 4/5 is 0.8. So are those equal? those are not equal. So you would say no, AB is not parallel to XY. Okay, and now here we have a problem that goes with that third theorem where we have 3 parallel lines. Okay, so it wants us to complete the proportion. What goes with what? Okay, so UV goes with UW. Oh, does that work? Yes, it does. UV is proportional with UW, just like XY is going to be proportionate to XZ. Okay, and then the next one is XY goes with YZ, just like something goes with VW. Well, that something is going to be UV. Okay, and then the last one, something goes with ZY. Okay, just like WU goes with WV. So it looks like we're going to have ZX here. ZX. Okay. All right. So that's kind of how those proportions can be set up. So now let's look at our diagram and solve for DF. They want us to find DF right here. Okay, and DF is this whole spot right here. So let's start by setting up a proportion. We can say that DF goes with 35, right? Just like this whole guy goes with 30. Okay, and the total is going to be 30 plus 12, so that's 42. And now we cross multiply. So 35 times 42 is 1470. And then divide both sides by 30. And we get 49. Okay, so that's it for those. You can just kind of set up those portions into ratios to find the missing stuff. Okay, now we have another GeoGebra activity if you want to go to this website. I have it pulled up here. This time we have an angle bisector, okay? And here's all of our ratios. Okay, I can move this triangle. See how the angle bisector stays an angle bisector? And as I move this, these ratios are staying equal or proportional. Okay, so AC and CE, which are, the ones on the side, those ones go together, and then the ones on the left side, AB and BE, those are proportionate. But you can also say that BE and CE are proportionate, just like AB and AC are proportionate. So you can kind of play around with this. You could even move, you're supposed to be able to move this out, but maybe not. Oh yeah, there we go. Okay, so however you move this, it'll show you that these ratios stay equal. So this is our next theorem, the Triangle Angle Bisector Theorem, which says that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So let's write down the two proportions, okay? So we can either have CA goes with AD, and that will equal CB and DB. But we can also say that CA goes with CB, and that's proportional to AD and DB. Okay, both of those proportions work. Okay, so for number 6, it wants us to solve for x, so I can say that 9 goes with x, just like 15 goes with 5, cross multiply, divide by 15, and I get my missing side, which is 3. Okay, I can do the same thing with number 7. 42 goes with 18, just like 63 goes with y. Cross multiply. 63 times 18 is, well, I didn't actually figure that out. Okay, divide by 42, and it equals 27. Okay, and that's how you use that theorem. Next, work on the puzzle and your homework. Good luck.